Hello and welcome to this Simulator Spotlight presentation. My name is Jason Tranter, and in this presentation we'll take a look at iTeachMotors. And as you can probably imagine, this simulator helps us understand how electric motors, primarily induction motors, how they work and why the vibration changes the way it does. This simulator really allows you to understand all the magnetic forces and why the vibration changes when we've got broken rotor bars or problems with the stator, eccentricity, all sorts of things. And it's an attempt to show in software exactly what's going on. Now, this is a case where we could really spend a lot of time explaining it all, but I'll just quickly show you some of the features. The first thing that we're trying to do right at the start is just to show why we get the twice line frequency vibration. In this case, you see that for half the cycle we get a strong magnetic field developed in one direction, and then for the second half of the cycle, so we've got one half of the cycle where the current's flowing one way, and then the second half of the cycle, this part, we get another strong magnetic field. So twice per cycle we get this strong magnetic field. So everything in the laminations and the windings, we get that strong pulsation twice for every cycle. So if we've got 50 Hertz or we've got 60 Hertz, then we're going to get a strong vibration at 100 Hertz and 120 Hertz. So we spend a bit of time with this. We've got other animations that support all of that. Then we can talk a little bit about how single phase motors work. And we can go through and talk about magnetic field and how we wind the rotor so that we create this magnetic field, and we have this change as such. And then we look at three-phase motors. So here we've got the three phases wound 120 degrees apart, and we see. So we can just start with an explanation of the three phases. Then we can see the summation of those two, and because we get that moving wave, here are the windings themselves, one phase in red, another phase in green, wound 120 degrees around, and another phase in blue. I'm really rushing through this, of course. We're not here to sort of explain how motors work, but thanks to this pulsating magnetic force we get with each series of windings, we get a rotating magnetic field, and that's that black vector, that black arrow moving around. And so another way to view a motor, which is as a rotating magnetic field. It's almost like we literally have the stator spinning, creating a magnetic field. So we've got a strong north-south magnetic field rotating round and round and round the stator. So then we have to say, well, what are we going to do about that? Well, what if we created a motor that had a permanent magnet? If the rotor was a permanent magnet, well, that permanent magnet rotor is going to chase that magnetic field around, and if it's not centered, there's issues and so on and so forth. But that's one way to do it. Another way is via the synchronous motor with windings. In fact, I can just slow that down a little bit. There we go. So there's the magnetic field generated by a series of windings in the rotor, but because this is separately powered, we have a magnetic field established here and the rotating magnetic field established here, and therefore this rotor turns at the same speed as our rotating magnetic field, and that all depends whether it's a 2-pole motor, 4-pole, 6-pole, or whatever. And then finally, of course, we get into the induction electric motor. And in this case, now each of these are the rotor bars, and they're not powered, but when you start putting this rotating magnetic field, the current is induced in these windings. That current generates a magnetic field, and it starts to chase the magnetic field. But it can't catch it, because if it was turning at the same speed, then there would be no current induced into those rotor bars, and therefore it wouldn't chase the magnetic field and it would slow down. In fact, you can see this black line represents the turning, rotating magnetic field generated by the windings of the stator, and you can see how the rotor is not turning at the same speed. There is a slip it is moving slowly behind. And in fact, if we look more closely, as that strong part moves over each one of those rotor bars, you can imagine that generates a certain force. And if just one of those rotor bars was damaged in some way, so okay, in one case we've got static eccentricity, so for some reason that rotor is off center, so the vibration is going to be very strong here. You know, these two magnets, if you like, are very strong, and we're going to get that 100 hertz or 120 hertz vibration in that case. Of course, it could be close at 2 points depending on how the stator is deformed. We can have a rotating eccentricity, so now we've got this strong point here, but it's chasing the magnetic field around, and that creates a different sort of vibration which we can see. And you know, as we can see, these rotor bars come into this closer point, move out, in, out, so that's why we get these pole pass sidebands here. And if we actually have a broken rotor bar, now we see this this one broken rotor bar, so as it comes in and out of the magnetic field, we see a certain vibration. So that's the pole pass frequency. And we can play around with the line frequency, we can play around with the load, we can induce more slip, we can look at 2-pole, 4-pole and 6-pole, lots of things. So there's a lot you can do, and with some of these simulators you might see them and think, yeah, there really are quite a few options. But of course, as part of a training course where we're also using all of our 3D animations and really cool animations showing the rotor and the stator and, you know, magnetic fields, it all looks great, but this helps us to explain it more interactively, because we can change the amount of load and see what would happen to our pole pass sidebands and so on and so forth. So anyway, that is a quick introduction to the iTeachMotors simulator. I hope you enjoyed the presentation, and thank you very much for taking the time to view this presentation.